Hey, this is Jason Kanigan for Make Space Boring News. I'm here with Justin McKennon, Principal Scientist at Electromagnetic Applications. Thanks for joining us.
Glad to be here.
So, why I wanted you on, and you stuck your hand up as well to make sure that I noticed, which is great, is we're interested in stories of new space technology that's coming out and potential use cases for them that might be surprising. So, I hear you've got one for us.
I do. So I guess the way that I would describe it is if you're a company that wants to put something into space, you're probably aware that you can't just drive there. You can't mail a box to it there. It's quite an effort. And, it takes a long time to get on an airplane to go one place. It takes even longer to get on a rocket. And a lot of the technology that's currently being used in space is horribly outdated for that matter. So you need to have millions of dollars and many months of calendar time to evaluate anything in space. And it's not feasible. So one of the things that we decided when we began looking into space areas there is how can we make space accessible to everybody? You can't have a situation where the window of usability cannot be met by the time domains that you have to get stuff into space. And so what we've decided to do is replicate the space radiation and space plasma environment to make it accessible to people that don't have the time or money or desire to wait for an entire calendar year to vet new technologies. And if you think about it, you can't really touch things and feel them when they're in space. You fly something on the International Space Station, you put it on a satellite, you got to wait a year for it to come back, and you kind of hope you can figure out what happened. Well, that's not good enough. If you're going to develop a new material or a new product, you want to see it, you want to watch it move, you want to see how it's going to behave, how it evolves, and then that gives you a really darn good business case to present to folks that are already doing this. And we think that that's going to open a lot of doors for people to really advance space technology.
Okay, so as I understand it, you've created a test environment that simulates space with the radiation. How are you dealing with the microgravity?
We're not doing too much with microgravity at this point. We've actually looked into doing additional chambers there. And the reason being is that surface contaminants is another big one there. You'd be running all junk out there, the dust and particles on there. And they don't really mix too well in the radiation environment. And so we've tabled both that, the microgravity problem, and then some manipulatable plasmas for a separate chamber.
Okay, so this is more focused on the radiation measurement side of things.
Right. So if you're SpaceX or you're Amazon or any other large company right now, protons and single event upsets are hugely important. And if you're not aware, what SpaceX does is they rent out proton accelerators at a hospital, overnight when the hospital's not using them. And if it's something that one of the most well-known space companies in the world is required to do, there's probably a few other people that would be interested in that as well. And so that's certainly a challenge that we're taking on. NASA, of course, has a ton of interest in it. Johns Hopkins and a number of other groups that are sending things really far out into space. But the problem is that these aren't high volume projects. And so there's really not a lot of opportunity for a company to take on large scale materials development and things like that. If you make an insulator that's perfect to go to Jupiter, they're only probably going to send one thing there. So you can't really stake a business on it. So there has to be some cost trade-off with it there. And from a technology standpoint, we think that making it easier and at a shorter time domain makes it feasible to look at those types of applications.
Okay, so this company is all about helping other companies scale up fast. And so that that is news to my ears here. So you've got this new capability. Where can people go to connect with you, find out more?
Well, we're all over LinkedIn. You can certainly find us at Electromagnetic Applications, or you can email any of us. My email is pretty easy. It's justin@EMA3D.com. We're happy to answer any sorts of questions there. We're also pairing this with a simulation tool that'll have similar capabilities to that. The way I always describe it is you have to have something in order to test it. And that means you need people and processes and materials and design reviews, and the list goes on and on there. And we think that if you had a tool that was as modern as the test capabilities, you could probably do a better job of picking and choosing what you test. And so that, I think, gives another option for people to cost effectively evaluate engineering designs for space.
Awesome. Well, we'll put a link or two in the description below. Thanks for joining me, Justin, to share this capability.
Much appreciated, Jason. We'll talk to you soon.